Oh, hello there, Travis. What are we actually seeing starts to get complicated? It was easy. It will start to separate. Are definitely not behind that restricted access gate. They're not. Forget about it.
None of them will be able to be revived.
So please, being reasonable, returning to the orientation you usually is the private traditional. A stabby, but I don't think. And those rectangular outcroppings weren't. Here is my Catwoman glove and glove. I should have a floating, impossible anti-gravity blah blah blah. Now, if we were to take it, snapshots, eventually, how do you transmit a discrete shells?
Well, Aria, we've been tracking this thing for weeks and we still don't know what it is.
The basilisk has its eyes on you. What are you going to do? And at some point, the acceleration is going to get so high that you're going to pass 9.8 meters. Look, I know that neither of those examples were fun. A screaming fish on this side would never be fun, leaving me weightless no matter where I am. What the? We generate our truth endogenously or within our own bodies.
I give killer high fives.
Is it? Is that it? This story is only one of a dozen. Okay, good, because it's rock, paper, scissors. Where are you right now?
Bam.
The fingerling. That fingerling. Isn't that wild? Fingerling.
Here's good coffee. Oh, I'm sorry, what were we talking about?
Space. The final frontier, they say. And what do we find out here in the final frontier? Planets. Stars. Did you know that there are stellar earthquakes? But we're not talking about stellar earthquakes today, even though it's super, super cool. No, today scientists have discovered and uncovered out here, in the grand void of space, that not only are there hurricanes within weather systems of planets within their lower atmospheres, there are space hurricanes. Welcome to Office Hours. Hello and welcome to Office Hours, the live component of the facility where good old Professor Kyle opens up his blast doors, as you could easily see there, and he lets the members of the general public and all of his faculty and staff ask him any old sciencey, pop culture-y, physics-y, engineering-y question, and I try to be as entertaining and as educational as possible. Of course, we talk about a number of topics each week. I don't know if I'm going to get to all of them this week because I feel terrible. We'll be talking about octopodes and, I got to remember that this is actually the second one, space hurricanes, lab-grown meat, monkey. And finally, we'll be talking a little bit about fake news and how you're much more susceptible to it than you think, which you probably knew. But before all that, I just wanted to tell you that if you want to join the facility, if you want to continue on this conversation, you can, of course, go to patreon.com/Kyle Hill and join the facility today. Drape on a silky white lab coat, Simp for Science, like you can see everyone in the chat doing. That's all going towards our work here at the facility. My security team should be putting in the chat. Please be nice to my security team. They have both beef and castles and wrenches and buckets, and they're not afraid to use them. Of course, if you really, really, really want me to see something that you say, you can try Super Chat. I can't promise I will answer every old question, but I will try my very best before we get into and in between these topics. For example, Elizabeth Calvert, as always, hey Liz, with the $50 donation, says, "Hey Kyle, I hope you and your calculator friends are doing okay this week." Yes, thank you. My calculators are doing just fine. Of course, TI-89 titanium. My tiny human Alex wants to know two things. First, how old is the Earth, and why do combustion engines not work without fuel? Well, tiny human Alex, the Earth is about 4.6 billion years old. We can find this out by comparing how much... by comparing the kinds of atoms that we find in really, really old rocks to the ratios of atoms that we find in much newer rocks. And comparatively, if we know the age of one or the other, we can use the ratios of those atoms, and since we know how they decay over time, these are nuclear materials, we know how they decay over time, we can work backwards or forwards to say, well, if this had X ratio of nuclear decaying atoms in it at this time, then based on the half-life of these materials, it should be 4.6 billion years old. And a combustion engine doesn't work without fuel because you need something to combust. Literally, you need to blow stuff up. So we're blowing up the gasoline that goes into your car, and we use this rapid expansion of gas to push pistons, physically push pistons, which starts everything a-going. And I just noticed because of this new camera and the forced perspective here, I look enormous. That's great. These are the kinds of things you can get from Super Chat. Mr. Diglett is always with the 20. Notice I also have a fancy new microphone arm. So now, look at me. I look just like a streamer. We have Liara Noel. Beautiful name. With the $100 donation, it says, "Hey, Kyle, longtime fan. You really inspire me to look at the world in new and exciting ways." Hey. Have you heard of Isolation 00? He does a lot of detailed breakdowns of the science in the Halo universe, like Master Chief's telomeres augmentation. I'm guessing that helps John 117 not age as much. I get it. Would you collab? Sure, I'll look him up. And before we get into today's first topic, we have Chef, one of my oldest supporters, with the 20, says, "Hey, love, show the Kyle and all hail the basilisk, of course, and the demon and the foot." Who's your favorite Belta Loda, boss man? Simp for the cant and the science. I really like Anderson Dawes. Man, and he's played so well by that actor. I forget his name, but he's absolutely fantastic in that role. And of course, you know, my voice is pitching? What does that mean? Anyway, and of course, you know, The Expanse is my favorite television show on not television. You get it. Let's go on to our first topic. Oh, peaking. All right, let me turn... Yeah, I was having microphone troubles earlier, so let me just turn this down so that I'm not peaking. Is that better? Is that better, my baby birds? Oh, wait, this is the wrong... Kevin! You have to open the door to the other room. Is that better? Not peaking so much? I can see it. I can see it. Look at this, real time. Space Hurricanes. Still peaking? Ugh. 1 second. How about now? We still good? We still good? I don't have all day to do this. Good, better. Okay, so space hurricanes. So space hurricanes are like normal hurricanes, but how? That's why the scientists named them that. Well, recently reported from data that was collected a lot earlier, we've found in the upper atmosphere of Earth, a few hundred kilometers above the North Pole, in fact, we've found what scientists are deeming a space hurricane. Now, you can say that it's a space hurricane because, specifically, it is in space. Where is space, Kyle? Well, space is, we define it at the Kármán line, somewhere down here, 100 kilometers up. That's where the pressure differential between atmosphere and no atmosphere is effectively nothing. So there's no, like, space beyond it. Well, I mean, there's no pressure beyond it, and so it just must be basically space, when the pressure just asymptotically goes to near zero. So space at the Kármán line is about 100 kilometers up, 62 miles or so. This is a few hundred kilometers above the surface of Earth, which means this is indeed space. But what indeed is it, Kyle? Well, like swirling clouds and thunder stuff, this is an artist's representation of a 1,000 kilometer wide swirling mass of plasma. And it's in many ways resembling a hurricane. How? Well, first of all, it's a giant mass of air. It is moving like convection currents cause hurricanes in the lower atmosphere to move. And instead of rain, it is raining down charged particles like electrons. Now, what's interesting about this is that this data shows us that this should be everywhere. Everywhere with a upper atmosphere and where charged particles can gather, things with planets with magnetospheres, there should be space hurricanes here. or on other planets. And indeed, when the scientists went back and looked at previous data they started collecting, they found a lot more signatures of what probably were space hurricanes on Earth. Now I'm really quiet. How about that? Now that's speaking. This is dumb. How about that? Anyway, get back to me. Why is this all important? Why is it interesting to know about space hurricanes? Well, this is something that we've never observed before, and it is during a period in which we don't expect a lot of solar activity to create these space hurricanes. And that's interesting because we would expect a lot of solar wind and a lot of solar activity to be providing the charged particles that swirl into these space hurricanes in our upper atmosphere. So that has implications for practical things like launching satellites and our communications equipment. Much better. Okay, now everyone shut up. Satellites and communication equipment, because these charged particles can ionize material up in space, and more deadly for these materials, for these electronics, it can induce, with electric fields and magnetic fields, it can induce electric currents inside of our hardware. So that means that it can fry electronics. And this is what you hear. This is what you hear could be a huge problem if a giant coronal mass ejection or solar flare hit Earth and it bathed us in all these charged particles, because then it could fry all of our equipment and send us back to the Stone Age. People always say Stone Age, but it means bronze. They probably mean like Iron Age, right? I mean, we'd still have all that iron and stuff. So what did all of this look like? Well, you can see that the space hurricanes themselves and the electron precipitation, that is a cool name for a science band, if you ask me. But you can see that the space hurricane is pretty dependent on the field currents, electrical and magnetic field currents above Earth's surface. And if you look even closer at it, or more closely at the fields, but further out from the... Shut up. You have Earth's magnetic field. You see where the space hurricane is here, extending up into our upper atmosphere, almost corralled by these magnetic fields here. And again, given that this is the first time we observe this has practical implications for observations on other planets, observations in the upper atmosphere, and what we can do in space and the upper atmosphere for things like Starlink and that sort of thing. So all this taken together is a space hurricane. And I say that they're pretty cool, but you know what? I want to hear what you have to say. We have your friendly local cryptic, another one of my facility staff members. Hello, cryptid, I think you mean. Anyway, with a 19, says, my alarm goes off in 7 hours, so I can't watch, but I'm still simping. You see that? Dedication. Science takes dedication. It also takes money. But it's just a fact of life. We have Hat Trick with the 20, says, assuming we can solve the propulsion issue problems, do you think we could feasibly make a populatable space station first, or go to asteroids first? Do we have the resources for a big space station and that kind of thing? Well, we already have a space station. We already have an international space station, of course. So I think there's a much better case for having just a large... Oh gosh, you were all just waiting. Much better case for just making a larger space station rather than doing something that is unproven, like landing on an asteroid and spinning it up like they do in The Expanse. And keep in mind that putting things up into Earth's orbit and setting them in orbit yourself like the International Space Station, could be much easier than trying to get to an asteroid, because, as they say, rendezvousing with an asteroid is something that's non-trivial. It's very difficult. these asteroids are screaming through space at many kilometers per second, and you have to perfectly match their velocity over months and years, or however long the mission and the Hammond transfer is going to take you, or what have you. So there's a lot of logistics involved in setting up on a colony that's moving relative to you very, very quickly. I'd say that setting stuff up in low Earth orbit, pushing it out into higher Earth's orbit is probably easier to have like a space station, to have like a, what do they call it in Neuromancer, but having in like an orbital city would probably be easier. Because just colonizing some other body in space, you are naturally dependent on some of the conditions of that body. And as we know, or I think we talked about, asteroids and comets and stuff like that, they can have compositions and local atmospheres that are completely counterintuitive. Like, they can be so soft you could swim through them. So that's my take on that. Paulie San with the 20 says, show the love, Kyle. Hey! No question. It was just answered by PBS Spacetime this week. Sorry you're sick. Have a beer on me. Oh, I'm not sick. I just feel terrible. Where did you go? We have Morgan McHenry with a 35 who says, hey, show, love the evil super genius person. Hey, thanks. Question for you. Once the general public is fully vaccinated, do you plan on doing some EDH at nearby Magic Fest? Would love to play some games with my favorite science communicator. Well, thank you so much. Absolutely. I went to Magic Fest Vegas right before, before lockdown, and I had a ton of fun. I met a ton of awesome nerds, and I still have, actually, my lanyard is right here for that. So yeah, absolutely. We'll grab a game. John Hinkle with the 25 says they should call it the analog age because only circuitry will be primarily affected. Yeah, we should retire phrases that aren't accurate. I agree. Thomas Hadrick is answering Tiny Human Alex's question. Check out some of Neil deGrasse Tyson's Cosmos series for a wonderful animated story about the precise moment the age of the Earth was discovered. Oh, to Director Hill, I think some Proto-Kevins escaped the containment from the cloning lab. 1 second. Yeah. No, you have caller ID. It's no one else calls you. Anyway, yeah. Thomas Hadrick, talking about a cloning lab. Yeah, no, I don't know what he's talking about either. Yeah, that's probably the safer option. Okay. Get it done. Bye. Love you. Don't worry, Thomas. Someone will be on their way shortly to thank you for your service. It's already rendered with the 20. It says, hey, Science Thor, love the show. If genetic splicing from Batman... Do you mean splicing? From Batman Beyond was real, what animal would you splice with? I would splice jellyfish DNA into my body so that I could glow in the dark like those kittens. We have Cheech Ola with the Australian $31, who says, question about the Andromeda paradox. Does the thought experiment imply that if two nerds from Andromeda viewed Earth, the walking nerd would see this moment now, and the still nerd might see a moment in our future? Yes. Why did my ear look so red in the color correction? So the Andromeda paradox is the paradox that has to do with the relativity of simultaneity. And that means that when things are separated by a lot of distance and are moving differently, their slice of time that they would report that they see could be very different because time would move differently for relatively moving observers. And so if you apply that to something as far away as Andromeda, if you were just walking like a few miles per hour, like 1 mile per hour, you could see Andromeda like days in the future or the past, depending on whether or not you were moving or standing still relative to another person and you asked each other. The problem with the paradox is, of course, you can't instantaneously know what's happening in Andromeda. You can't see Andromeda from here. But because it's the relativity of simultaneity, that means, yes, someone in Andromeda, depending on how they're moving relative to an observer, they're also asking that they could see Earth at two very different times, years in the future or past. Yes, that is technically true, the best kind of true. M. Harder with the Canadian 5 says, "Hey Kyle, I'm a Pisces, waiting for the eye roll." Here, I'll give you one. Astrology, jeez. I just want to thank you for all your work and keeping us interested in the world of science. Hey, I'm doing my very best. I'm doing my best. You should have seen how long it took me to figure out this stupid new camera. It has like a fisheye effect. I was so bright for so long. One of my security team, Jay, with the 19, says, "I like cheese." Okay. Kevin Wiltshire with the Australian $10 says, "Hey Kyle, I love the show and your ability to make science more approachable." Don't put science in quotes. It's a proper noun. Keep fighting the good fight. My question for you is, what do you think of the biocentrism/consciousness theory? I'm sorry, Kevin, but I have not heard of it. Does it mean that biology itself is inherently conscious? I don't know. I don't know what it is. So I don't know the answer. Or I don't have an answer, so I'm not going to say it. Dr. Andy Hill with the 20, my brother, I guess, desperately trying to think of a sensible question, but currently discussion not my area of interest. Hey, man. I'd like to ask you a question, but you're not talking about anything I find interesting. Hey, man, that's fine. Spasmodius says, "Hey, Kyle, huge fan. Hi, best live stream on YouTube. Thank you for being awesome." No problem. Man, what a fun voice you have. And with that, let's pause the super chats for just a second so I can talk to you about one of the coolest animals in nature, for sure, and that is octopodes. What am I saying? Yes, if you really want to be pedantic about it and annoying, octopodes is an accepted pronunciation of octopuses. I mean, it's an accepted pluralization of octopuses. So go ahead, say it. It's got a good mouthfeel. Say it for yourself. The creature was slain by octopodes, ruler of the 8-armed castle. I don't know. Shut up. Okay, so I put this question to everyone in all my staff in my facility Discord. I wanted to see what was more clickable, and you said this was second as clickable to Space Hurricane. So now we're going through this, and what it is that octopodes have more emotional intelligence than you think. Now, when we say intelligence, we can mean many different things. We know that octopuses, I'm not going to keep saying it, are one of the most, probably the most intelligent invertebrate. And they display amazing feats of intelligence. They have this alien-like distributed intelligence in their arms, how their nerves come out from a central nervous system into their arms, where their arms can act somewhat independently. They have incredible adaptive capabilities, physical capabilities. They can move through small places. They can change the color and texture of their skin in many cases. They are absolutely amazing animals. And we know that they're smart. But like I said, when we say smart, humans mean that in a couple different ways. And I think when humans mean smart, it's one of the ways that humans judge whether or not they can eat something, right? So I think it's pretty common to draw that comparison, right? Even if you're not thinking about it, I could probably determine what animals you consider very smart or capable of feeling and experiencing based on what you would eat or not. So I'd bet that many of you have tried octopus, have eaten octopus, and haven't given another thought. I have. But you probably wouldn't try a dog, right? Because we get this moral sense to us that a dog would experience and feel pain. So wouldn't it be interesting if an animal we do not associate with that kind of intelligence had that intelligence and we could prove it? Well, enter into this new study appearing in one of the most reputable journals in science, cell. So this is a new study about whether or not octopodes can feel pain. Not just that they experience pain, do they have a lasting feeling of what pain is? Do they experience pain in the same way you experience pain? You don't just avoid it. You remember the experience and you actively don't go do that thing or go to that place anymore. If we could show that kind of thing, then it would be the first time that it's been demonstrated in an invertebrate, even though that pain avoidance has been demonstrated. So these are I'm kind of rambling a bit because I'm teasing out two different distinctions here. That's redundant. I'm not Octodad. I'm not your Octodad, Darren. You lock it up. Anyway, this study in Cell has this, and I've never seen this in a science paper before, but I'm so all about it now. This is they included a graphical abstract that basically tells you everything you need to know about the study without saying one jargon-filled sentence. And I think that's incredible. So, what did they find? Well, first you need an experimental setup to test a creature that can't talk to you, that can't write down what it felt, that can't, do that kind of thing. So the test setup that the scientists wanted to use was just a box. And the box had 3 chambers. The chamber either had stripes, it had nothing, or it had dots. I don't think they could inhabit this area. So they were either confined to stripes or dots like this. So in session 1 of the experiment, as you can see here, they let the octopodes explore whatever, freely explore for 15 minutes. And because these are intelligent animals, they discover preferences for where they want to be for whatever reason, and they will go and stay there. So first 15 minutes, they let these tiny octopuses inside of this tiny box, and they let them explore around and see what, quote unquote, their preference was. Okay. Now in session 2 of the experiment, that's just to get them acquainted with the experimental setup, because if they weren't first acquainted with the experimental setup, you couldn't prove that the newness of the setup wasn't an additional variable that you had to control for. So they're controlling for it by exposing the octopodes early. Now in session 2 of the experiment, what they did, and this sounds, not super nice, but science isn't always super nice. They either injected one of the octopus's arms with saline, which is to say basically nothing, or they injected acetic acid under the skin. Now, this doesn't cause, a lot of damage, but it does create a feeling of pain in animals. We know that. If I did that to you, it would hurt. Okay. So now we have a pain stimulus. Another component of session 2 to tease out more variables was either injecting acetic acid or lidocaine, something that would relieve pain, but it wouldn't do anything aside from that. It's not going to get the octopus high, but getting an octopus high does sound fun. Anyway, catnip is the only recreational drug that we give to animals. I hope you know that. Cats get really high. It's a hallucinogen, and it's the only drug we give, only drug like that we give to animals. Anyway, so now they're teasing out other variables in session 2 here, and this lidocaine is not getting the I want to say it every time. The octopus is high. Instead, it is relieving any pain that they might have felt or do still feel. Okay? So then in session 3, so they injected them in session 2, and then whichever side they went to, they confined them there for another 20 minutes, as you can see. Then for session 3, they let them back out and let them decide what side they preferred. Now, what did they find? Well, we go back to the very helpful Very helpful graphical abstract. And you can see in the condition where there was no pain and they were injected with saline, again, nothing. They have no pain. There's no activity in their brain and central nervous system. And where they, in this abstract, the octopus in question prefers the striped side. So this makes sense, right? If the animal prefers the striped side, you inject it and it doesn't cause any pain, the animal stays there. And again, you might be saying, why inject the animal at all then? Well, like the introduction of the chamber, if you don't inject something, a placebo and the variable, or a control in the variable, then you can't rule out the variable that the needle itself made a difference. Not what's in it, just the needle. So they had to inject them in both cases. This is what going to grad school is like. Okay. So this makes sense. The animal stays in its preferred place because nothing told it otherwise. It didn't feel anything. But now we have the noxious stimulus, the second part of our graphical abstract here. And you can see that based on the readings from its central nervous system, when it was hooked up, it had a lot of activity in its CNS. It was feeling pain. And we could determine that by the fact that the animal, again, in the second part of that graph, moved away from its preferred area, right? That also makes sense. If an animal is in an area and you zap it or you inject acid under its skin, it's probably going to move, right? You'd move if I injected acid under your skin. Probably. Kevin, how much acetic acid do we have? What? Oh. Sorry, I was just subscribing to some magazines. So now we have things that make sense. We have proven, or the scientists rather, have proven that octopuses can feel pain. But now we get to the meat of the study, which is, do they feel pain in the way that you and I feel pain, in that they experience pain? Because you can flick a bug and the bug will move. It doesn't want to be there. That's an evolved response to a pain stimulus. That's easy. But the question here is, well, here I'll tell you what they found. So when they paired, on the last part of the graphical abstract, when there was no pain being felt, and they were injected with this lidocaine mixture, so they were actually feeling no pain, and they were still injected, they refused to go back into the striped area. Now, this gives us a sense that if they very much preferred it before, and they refused to go back, even when they were definitely not feeling any pain, that gives us some sense that there is a lingering tail of some kind of emotional memory here. That something that will eventually decay with time, of course, but because this was so quick, I hear what you might be saying right now. Kyle, couldn't this just be a conditioned thing where you just keep injecting the animal over and over and over again until it doesn't want to go there? Well, this was just a session or two, which means that which gives us an idea that the octopus had a feeling of what that pain was, such that it refused to go back even when we knew it wasn't feeling any pain. So to go against your place preference implies that you feel the pain in a way that's not just a easy response to a stimulus, right? So what this all means, I think, taken together, if you were to ask me, or what the rather, I'll let the scientists conclude. they say, quote, together, these data provides, data is plural, by the way, if you didn't know that. Together, these data provide strong support for the evidence of a lasting negative affective state in octopuses, so the feeling of pain. This is the first evidence for pain experience in this neurologically complex invertebrate clade, so this group of animals like this. The functionality of this pain experience, they go on to say, rather than just chemically feeling pain and responding to it, nociception, feeling pain like you feel touch. The functionality of pain experience in cephalopods is not yet clear. Pain has been hypothesized to be an adaptive primarily among social species where injured individuals can recruit help from other members. And it's also cited as an adaptive mechanism for reinforcing contextual memory that lasts throughout life. And again, I'm quoting here because this is a good part of this study. Although the octopus is often described as being vertebrate-like in cognitive ability and intelligence, its asocial habits, short lifespan, and severe nutritional costs of recuperative inactivity argue against the prevailing evolutionary hypothesis cited for the evolution of pain in vertebrates and instead suggest a wider, more ecological perspective on the evolution of pain and of the affective state. So, what I'm getting at by talking about all of this is that it's very possible that animals that show this kind of this different kind of intelligence can be intelligent in a way that we don't expect them to be. And that means we need to continuously, as we do the science and we do the biology, we need to continuously widen out our moral sensibility for how we treat the other creatures on this planet. After hearing all that, I know I didn't explain it super well. It was a confusing control situation. But after hearing all that, I don't think I'm gonna eat octopus. This study seems fairly confident in its conclusion that they experience pain. They don't just feel it; they experience it like you would. So in the face of that, would you really want to look in the face of this and say, Om Nom? I don't know. You're going to have to make that decision yourself. Yeah, got a little weird at the end, huh? We have Jonathan F. with the 10 who says, Hey, Kyle. Hey, Kyle, huge fan of you for a long time now. I'm stoked to see your channel grow. Oh, curious if you've seen the V-Shred commercials on YouTube and what you think about what he's doing. V-Shred. No, I have no idea what that is. Let me look it up without hitting any hotkeys. Oh, it's a diet. I have no idea. I'm currently, I wanted to level up my life in the new year, so I'm currently working with a personal trainer, and he's helping me get in shape because I'm tired of people objectifying me so much on the internet. Joseph Anson with the 20 says, thank you for being the best part of this time we are living in. Hashtag Sim for Science. That cannot be true. The best part of this time that we're living in right now is that a bunch of scientists rushed out a successful vaccine in record time, and we're saving people's lives. That's pretty awesome to me. Grim Reaper of Trolls, don't worry, I saw your previous ones. With a 19, says, I've worked around acetic acid. It kind of sucks. Also, I'd be careful not to earn the ire of octopodes. They're smart little escape artists, and I think they're capable of grudges. Also, no more calamari for me. Yeah, yeah, they form grudges. Actually, I don't know if I should tell this story. Anyway, I was speaking with a person, and they told me that saltwater crocodiles also hold grudges. That's a story for another time. Spasmodia says, I am so sorry I had octopus for lunch today. Please sacrifice me to Lola as payment to the Octodad. I'm not your dad. I only have 2 arms that you can see at the moment. New Necro says, I rationalize that all animals we omnon felt pain at some point. Well, that's probably not true, right? I mean, there's if the feeling of pain, if emotion, the experience of pain is related in some way to neurological robustness, then we can probably be pretty confident that something like an ant or a fruit fly with very uncomplex, very simple brains that are very small, like literally just, not that many cells, then we can be fairly confident that they wouldn't feel pain in the same way or experience pain in the same way that an octopus would. So, like I said, we kind of have to broaden out the spectrum of what we truly consider intelligent if that's what we're concerned about when we're eating things. If you don't care about whether or not something feels pain because you're a predator and you need to eat, that's a choice you can make by yourself. I'm not going to tell you what to do. I'm only going to tell you what's correct. Write it down. Banana Goat with a $9.99 says, "Hey Kyle, what's your opinion on the false vacuum theory? Sorry if I butchered that. I have no idea. I believe that's some kind of theory about how the universe might end based on the vacuum energy of the universe, which Einstein called the cosmological constant. I have no idea what it is. But if you want to know what it is, I bet it's in Katie Mack's new book, a friend of mine, Katie Mack. Z33, and let's pause the super chats for a second so we can keep moving on, of course. With the Australian $14, who says, "Does gravitational time dilation mean that inside a supervoid, that time inside a supervoid passes much faster than time inside of a galaxy? And if so, would the expansion of space occur at different rates in each region?" I don't think the expansion of space is occurring at different rates in each region, but gravitational time dilation is the relative slowing down of time in and around very massive objects. Okay, so, for example, when you stand next to the pyramids at Giza, time on your watch, if you could measure it with the most precise clock known to man, if you could measure it, your watch would be ticking more slowly next to the Great Pyramids at Giza. I use that example because they're heavy things. But, and this is one of my favorite sciencey romantic things to say, time dilation occurs with any amount of mass. It's only with a lot of mass, like a sun or a black hole, that you really start to get big effects. But when you're next to your loved one, time feels like it might be going more slowly, and it is, technically. Oh, Kyle, that's not romantic. Hey, I know a lot about romance. Elizabeth, again, my tiny human, gave me $10 to give to you. Don't let Alex buy things. And then he's going to start asking about V-Bucks and Roblox and all this other stuff that people my age make on YouTube for kids your child's age, and it's gross and exploitative, and they make so much money. Do you know how much money some of these YouTubers that use the same thumbnail and they're just like, "Oh, I did Roblox but I married my dad"? You know how much money they make? It's disgusting. It is. They're millionaires, and they're terrible. You want me to name names? I can. Tiny Human says, "Why do things look bent in water?" Now, that is a deceptively difficult question, Alex. Things look bent in water because light moves differently in water, and when light moves differently, it's not going to arrive. So if light moved different through water, let's just say it did this. Now it's going to, when I see it, it's going to look like that light came from a different place. And so when I look at it, my brain sees the object, but it also sees the object through water, and my brain is telling me, well, the light is coming from here, but the object's here, and then it looks like things are weird and different. And that's because the light moves differently. For a full explanation of why light moves differently in different mediums, where did I talk about that? Put it in the chat. I did an episode where I talk about refraction and diffraction and that kind of stuff. Put it in the chat, because right now we have to go to this. Or not. There we go. Nixon Nelson says, "What's your age, Kyle? Leave me alone. I'm timeless." Peer review. As I'm wont to do, I take a comment from the most recent episode of the facility that didn't perform very well, and it's something that makes me go, hey, how well. I highlight it here, and then I give you an honorary membership to the facility. You got acetic acid in my eye. Then I give you an honorary membership to the facility, and then you get a plaque from Kevin. This comment comes from the most recent episode, of course, again, about Godzilla versus Kong and what Kong's ridiculously slow speed would in fact be. Tucker Partridge, which I can't decide if that's the most southern name I've ever heard or the most British name I've ever heard. Hey Kyle, I have a science question completely unrelated to this video. Great. So the way Ant-Man grows is by extending the distance between atoms. Well, that's what my friend who advised on the movie said. But even he is like, I asked my friend, he literally looked at the script of Marvel's Ant-Man. He lives here. Well, he works at the facility sometimes, but other times he's at Caltech. He's a quantum physicist. Works at Caltech. And I asked him about Ant-Man when I was making some Because Science episodes. And I asked him about the mass problem. Like, where does all the mass go? What about its density? And he's like, eh. So, if hypothetically Ant-Man were to grow to the distance between where the distance between atoms is like 8,000 miles, would he fall through the Earth? At some point, would he become invisible? So, if Ant-Man was able to push electrons away from the nuclei of his atoms, at some point would he fall through the Earth? I don't know. Would he just fall through the Earth? Well, the problem being is, I'm going to guess there's some limit on how much you could extend this shell of electrons from the nuclei of their atoms, because at some point those electrons are going to start interacting differently with each other. They're going to be at a distance that you as a structure of atoms kind of falls apart and you're no longer a thing. So I'm guessing you could disperse his atoms far enough apart that it could become something like a cloud of, Ant-Man plasma. But I don't know if... This is a weird question, because I'm having troubles with it, because you'd be dead. So the other thing is, if Ant-Man became so small, if Ant-Man shrunk down to ant size with human mass, he'd fall through the Earth in the way that you mean. Oh, in a different way. You don't mean this way, but he becomes so immensely dense that it would fall straight through the Earth into the core of the Earth and stay there and probably be dead. So, Tucker Partridge, thank you for your question, and you are now indeed an honorary member of the facility. And Kevin over here, he's got your plaque. Fantastic. Don't want to hit the mic. Fantastic. Oh my gosh, we actually have something for you, Tucker. Here it is. This is a bat in formaldehyde. You can see its ding dong. Well, what do you think a plaque means? Sorry, Tucker. That bat is named Bruce. Do you want me to talk about this last topic, about fake news, or do you want me to take your questions and comments for the last 10 minutes? You let me know. Hello, Kyle's Lair. Patrick says with the 5. Will we adapt our way out of biological evolution? Will our ability to change the world via technology make evolution unnecessary? No, evolution will always be happening. As long as we are replicating creatures in an environment, there will always be environmental pressures, and therefore there will always be, if we're always sexually reproducing, or reproducing with our DNA, there's always going to be random mutation, pressures on those mutations, and we will always evolve. I don't think we can remove ourselves from every single possible evolutionary pressure. There's always going to be something about the environment that would force some genetics to be better equipped at surviving that environment and passing on their genes or not. However, I do think technological evolution is already far outpacing biological evolution. I mean, glasses. I mean, think of how far ahead of trying to correct for poor eyesight that is, right? So we're already far ahead of it. What do people want to say? Ooh, a lot of fake news. Okay, I see a lot of fake news. So, I think, well, you know my thoughts on social media. I think it's a mistake. I think it's ruining democracy and the fabric of society, and I want it all to go away. And what has been supercharged by social media is fake news. Now, if you're watching this episode, you are probably, I'd say, within 10 to 15 years of my age range, which means I'm guessing you use the internet a lot, which means you have probably encountered fake news. But what I also mean by aging you is that you also probably think that you're immune, that marketing has no effect on you, that you know how to tell lies from truths, you know your political preference, you know who not to listen to. Fake news doesn't work on you. Well, you might know how to tell truth from fiction, but new study out recently has shown that you can be influenced by fake news without even knowing it, in a subtle, unconscious way. And that scares me. So, oh, wait, no. So, what research am I talking about? Well, I'm talking about a research, I should have pulled up a picture. I'm talking about research that asked participants to do a very simple task. And this simple task in different groups of people was just to ask them to tap as quickly as possible on a little sensor. Okay, seems easy. So, as a control, as the first session, if you will, if we're going back to Octopodes, a number of students, 200 students or so, were asked to tap. Just tap. And tap as fast, the scientist told them, tap as fast as possible. Okay? Then what they did was ask them to read articles. And these articles, unbeknownst to the different groups, these different articles had different frequencies of words and different framings for this. Okay? So they had different framings talking about tapping. These were articles about, studies on, how fast people tap and what it means about them, made up kind of stuff. But some of these articles used more words like intelligence and, attractiveness and those kind of things without explicitly saying it. It was subtext. And some of the articles were linking, again, not explicitly, but linking fast touching and stuff to being a criminal and to being unintelligent and unattractive, those kind of things. Now, after this introduction of these articles with these subtle words, with articles that were fully made up, fake news, fake studies, fake quotes and stuff. Now, what they were asked to do was tap again as fast as they could on this little sensor. And what they expected, what the kids expected, the students expected, was no change, right? They tapped fast before, they tap as fast as they can later, they read some articles in between, who cares? But it turns out, quoting from the article here, the fake news article that associated fast tapping with intelligence increased the speed at which participants tapped, even though all participants were instructed to tap at their maximum speed both during the pre-test and the post-test. There was no evidence that the participants were aware of their change of behavior. As such, this study demonstrates that fake news can successfully incorporate covert behavioral manipulations. And this is a brief, under 5-minute, one single exposure to a fake news article that is modifying the unconscious behavior of individuals. Now, this seems simple. No one's going to ask you to tap like that. And no one's going to be, well, they might be, but a scientist is going to come into your house and give you a doctored article. But it doesn't take all that much logic to extend this out to our current information environment. The information ecosystem, if you will. Now, like I said, tapping is very close to clicking. And the fake news in these that they were presented to these students is very similar to the kinds of stuff that is generated and amplified on social media that associates certain people with certain things, certain traits. And what's important to take away here is that this is unconscious. It's going to shape behavior. If it can shape how fast you tap, of course, we don't know how deep that rabbit hole goes, but if it can change your behavior, modify your behavior without you knowing it, at least in theory, then quote-unquote real fake news out in the information environment, out in the wild, could be doing the same to us. And this is being weaponized and supercharged by social media. So right now, well, the study authors provide a way to fight against this kind of disinformation, the spread of this disinformation and what fake news can do on social media explicitly. So on the left, you have disinformation like fake news, deep fakes, and then you have legitimate content. As that travels down towards the user, it goes through a platform like Facebook or Instagram or Twitter, and the platform can either mitigate that, label it as fake news, tell people that it's wrong, or ban it, or it can not do anything. It can claim, like Mark Zuckerberg, that it's just a platform and they have no or very little responsibility in that regard. Well, now the individual has some effective or cognitive resistance to the fake news, as you can see on the left. They know what they're encountering is fake news, and they can prime themselves to say, this is fake, I'm not going to let this get to me, I'm not going to spread it. But on the right, with no platform mitigation, no behavioral protection, this is an unsafe exposure to this fake news, which could, as the study shows, unconsciously modify your behavior. Again, it's not that crazy to think it not only modifying your behavior, but subtly modifying your beliefs. And then you're siloed into these echo chambers, and it becomes more and more modifying, and it becomes more and more of a problem. And if anything, this is just more evidence, more fuel on the fire that, as I've been saying, we need the regulation of social media, and we need regulation with teeth. You can't fine Facebook $1 million. That's not enough. They don't care. Like, a third of the people on the planet literally rely on using stuff like Facebook. And if you refuse to mitigate bad content, which we know is out there and we know is deceptive and we know is dangerous, then you have some responsibility there. You may have been a platform at some time, but you are now part of the fabric of society, and you're tearing it up by doing nothing. Just a couple more minutes. As always, thank you so much for joining me. We have a couple more time for questions. Yeah, Tommy KJ says, I gave up Facebook years ago. I haven't posted a single thing on Facebook in years. I don't use it. If you've added me as a friend, it's not that I don't care. Well, I do not care, but I don't use it. I refuse to use it. I think humans literally did not evolve socially to talk to other humans as though every person you've ever met is in the same room. I think it's psychologically damaging, and it's ripping society apart. So I don't use it. I do, but it feels bad because, of course, being the kind of person that I am, doing the job that I have to involve myself with social media and, live streams and YouTube and that kind of thing. I probably wouldn't if I didn't have to, but I love my job so much that I want to use the tools that I have, right? And not feed into it. Dr. Andy with the 20 says, parting comment as a fairly new associate professor of the facility. Yes, I am deeply embarrassed that my first super chat contained a keyboard snafu that made my comment insulting. I meant it's not my area of expertise. Yeah, Dr. Andy said earlier, I want to comment, but everything's boring. Thank you for clarifying that, Dr. Andy, and thank you for joining the facility. If you want to join the facility, if you want to get on our private Discord, if you want episodes early, if you want behind the scenes content, like photos of me poking dogs with lightsabers, you can go to patreon.com/Kyle Hill. As my security team is putting in the chat, everyone please give a digital round of applause for my security team for keeping so civil in there. We talked about a lot of stuff today. We talked about octopodes. We talked about space hurricanes. Monkey, not really. And we talked about your potential susceptibility to fake news. I hope that you have a wonderful rest of your weekend. This week up at the facility we have... What are we doing? Oh, I'm taking... As The Expanse was finishing up its new season, a lot of you were asking me on social media about airlock physics. We'll be getting into that, and I am now currently writing, I'm just finishing the script on our latest Half-Life history, which is a short documentary in that style about a very bad thing that happened to a guy. And that's all I'll say now. Have a great week. Let's finish it out strong. Let's take care of ourselves, take care of each other, because this is all we got. Get the acetic acid while they're not looking.